So this is an example of looking at concave and convex sections. So the graph of y equals x cubed plus x squared take away x has concave and convex sections. Find the range of values of x where the graph is convex. Okay, so looking at our notes from before, so convex is like a U shape. Okay, so here going down we've got a negative gradient. At our minimum point the gradient is 0, and then as we head back up our gradient is positive. So the gradient is increasing because it was negative, then 0, then positive. So that means our change in gradient, remember the second differential is the change in the gradient, is positive because our gradient is increasing. So that's what we're looking for with convex. Okay, so it's asked us about convex sections. So we need to find our second derivative and set it as greater than 0. So our second derivative needs to do our first derivative to begin with. So dy dx. So we've got, there's an imaginary 1. So 1 times 3 is 3. X, take 1 from the power is 2. Add 2. X, take 1 from the power is just 1, but I don't need to write that. Take away 1. That's our first derivative. Now we need to do our second derivative. So d squared y over dx squared equals 3 times the 2 gives us 6x, take 1 from the power is just 1, plus 2 times 1 is 2, take 1 from the power would be 0, so we don't need to write it. So that is our second derivative. Okay, so again looking at this, our second derivative needs to be greater than 0 for convex sections. Okay, so we're going to set, so we're going to make d squared y over dx squared greater than 0 to find where the curve or where the graph is convex. You don't need to write this. Okay, so I'm going to set that my d squared y over dx squared is greater than 0. So 6x plus 2 must be greater than 0. So you can either carry on here using your implies arrows. So we've got 6x is greater than negative 2, which means that x is greater than negative a third. So that's your answer. Okay, so the curve is convex for any value where x is greater than negative a third.